So we have a parallel circuit containing a 24 volt source, which we would of course consider to be VT, even though it's not labeled. 3 resistors in parallel, all directly across the source, so in parallel with the source and each other. R1 240 ohms, R2 200 ohms, R3 300 ohms. And we are asked to calculate the total current and the current flowing in each resistor. Okay, so the first thing is that the rules for parallel circuits tell us that V1 is equal to V2 is equal to V3 is equal to V4 is equal to VT, which of course we know is 24 volts. And so if we take that 24 volts and we go to our VIR chart and we write in 24, one of the things that we might realize is that we don't need to start with total current or total resistance here, because we have the voltage drop across each resistor and the resistance value. And so we could start this one by applying Ohm's law to each resistor individually. Now, typically we can't start a series circuit like that, but these parallel circuits we can. Okay, and so we could start off then by finding the voltage to each resistor and then use Kirchhoff's current law to find IT, couldn't we? And so the idea is that we have 2 approaches to the solution of this circuit, and it don't matter which one we take. And so think about the fact that we don't need to start off with an RT calculation for this one. Now that's what I'm going to do, but we could take the approach of find I1, I2, and I3 and then find IT and then do RT last. So RT first, RT last, right? Either one will do. Now I'm going to start off again by, like I said, finding RT. And so in this one, I can use the reciprocal formula, or if I got a calculator with a command line, I can make this a little bit easier by saying that this is equal to R1 to the negative 1 plus R2 to the negative 1. And I thought that was going to be a bit easier to try out. And so let's get rid of that. And so plus R3 to the negative 1 all to the negative 1. And so I suppose we're getting better as we go along. I'm getting messier, I think. 240 to the negative 1 plus 200 to the negative 1 plus 300 to the negative 1 all to the negative 1. And so you can type that in your calculator just like that. If you got a command line, push the equals button and out pops the total resistance. Remember, it has to be less than the smallest resistor, so you're expecting it to be less than 200 ohms. The other thing is that, look, if you put this in your calculator, put in 240, push the 1 over X button, plus 200, push the 1 over X button, plus 300, push the 1 over X button, hit equals, hit the 1 over X button again, and the answer comes up. So you don't need a calculator with a command line. The calculator, this type of calculation is really easy. And if you did it that way, you come up with a total resistance of 80 ohms. Now, you can use the reciprocal formula to find that value, remember that we can use product over sum, but you can only use product over sum for 2. So combine R1 and R2 using product over sum, whatever the equivalent of 2 to the minimum parallel is, combine that in product over sum with 300, and whatever way you calculate RT, you should come up with 80 ohms. Okay, so what that means is that I can go up here now in my table and put in 80 ohms. And so therefore, now I can start with Ohm's law and I can apply that to whatever resistor I want or the total. And so let's do the total current first. And so we have now IT is equal to the total voltage applied divided by the total resistance, and that gives us 24 volts divided by that 80 ohms, and so IT has a value of 0.30 amps. And so we can write that then as 300 milliamps. Now remember, that gives us an important piece of information about the circuit. And so we also need to think about the fact now that Kirchhoff's current law tells us that the sum of the currents I1, I2, and I3 will now be equal to 300 milliamps, right? So in my table up here, again, you know, we have indicated here that the unit should be milliamps, and so let's put 300 in there. Okay, so now let's start applying Ohm's law to each resistor individually, and I1 is equal to V1 divided by R1, and we have noted now that we have all the voltages equal in this circuit, and so V1 is VT at 24 volts, and R1 was 240 ohms, and that calculation gives us 0.10 amps or 100 milliamps. Okay, so 100. Now, in our circuit, IT is here, 300 milliamps comes this way. 100 milliamps goes to R1. It means that this current right here, Kirchhoff's current law also tells us, right, that if 300 milliamps comes into this node or junction right here, then 300 leaves. If 100 goes this way, then we know that this current right here is 200 milliamps. So the reality is that now that tells us as well that the sum of I2 plus I3 is going to be 200 milliamps, right? Okay, so then if we apply Ohm's law to resistor number 2, I2 is equal to V2 divided by R2. And again, the voltage is 24 volts. And we divide that by 200 ohms for R2. And if we calculate that out, it's 0.12 amps or 120 milliamps. And I need to have room to fit all that in there, so I'll just erase that for a second and try to put it a bit closer together. 120 milliamps. Okay, so in the VIR chart now, let's put that number in there. And so let's think about what that tells us. If I got 200 milliamps coming this way in the circuit and I2 was 120, I already know the value of I3, right? It will be 80 milliamps if the math is correct. So I can use Kirchhoff's current law to find that. Okay, 80 milliamps. Now we can write Kirchhoff's current law as, the current here, which call it IA, let's say, is equal to the sum I2 plus I3, and figure out I3 from that. Or, of course, by Ohm's law, I3 is equal to V3 divided by R3, and the 24 volts then divided by 300 volts. And so remember now, the biggest resistor is R3 here at 300 ohms, and it should get the smallest current, right? And if you do that calculation now, 0.080 amps or 80 milliamps. And so in my chart, 80, I'll check the math to make sure that that works out. 80 milliamps. Now, and so we got I1, I2, and I3. And so let's verify that Kcl holds true here. And so Kcl tells us that I1 plus I2 plus I3 is equal to 0.1 amps or 100 milliamps plus 0.12 amps or 120 milliamps plus 0.08 amps or 80 milliamps, and that sum now is equal to 0.3 amps, which of course is 300 milliamps. And that is equal to IT. And so that means that Kirchhoff's current law holds true, as we expect it should.